Good morning, students. Today we will discuss an important numerical from design of muff coupling. So let's see the statement. Design and make a neat dimensioned sketch of a muff coupling which is used to connect two steel shafts transmitting 40 kilowatt at 350 rpm. So in the first step you have given that you have to design the muff coupling and you have to make a neat sketch of it which is used to connect two steel shafts. The shafts are made of steel and the power we have to transmit is 40 kilowatt at 350 rpm. So one thing I want to tell you first is whenever you are given the power and rpm in a question, it means that you always calculate the torque because you know the formula that torque is equal to power into 60 by 2 pi n. In the second line we have given the material for the shafts and key is plain carbon steel for which allowable shear and crushing stresses may be taken as 40 and 80 megapascal. So it says that the material for the shaft and key is same. That is, it is plain carbon steel. And for it, the allowable shear and crushing stresses are 40 and 80 megapascal. So from this we can see that the shear stress is half of the crushing stress. We can say that the crushing stress is 80 and shear stress is 40. Whenever this case arises, you always choose a scare key. The material for the muff is cast iron. The material for the muff is cast iron and allowable shear stress is 15 megapascal. So as I have told you that in muff coupling you have three components. One is shaft, second one is muff, third one is key. The shaft and key are made of plain carbon steel whose shear stress is 40 and crushing stress is 80, and muff is made of cast iron whose shear stress is 15 megapascal given in the question, and power you have to transmit is 40 kilowatt at 350 rpm. So this is your statement. Now, how will you design the muff coupling? First of all, we will write the given data that power is 40 kilowatt, RPM is 350, shear stress for the steel, that is for the shaft and key, 40, crushing stress for the shaft and key is 80, shear stress for the cast iron, it is 15 megapascal. So first of all, we will design the shaft. Let small d is the diameter of the shaft. How will you design the shaft? There is always a simple rule for design of shaft that you have to calculate the diameter of the shaft. First of all, you will calculate the torque and torque is written as P into 60 by 2 pi n. Put the value of power and RPM and you will get the torque 1100 Newton meter. Convert it into Newton mm, 1100 into 10 raised to power 3 Newton mm. And this torque can be written as pi by 16 tau d cube and 1100 into 10 raised to power 3 is equal to pi by 16 tau. Here the value of tau is 40, that is for the steel, or we can say for the shaft, and it is 40 into d cube. From this expression, you will calculate the diameter of the shaft, and the diameter of the shaft is 52, and we standardize it up to 55 mm. Now, in the second step, you will calculate the design for sleeve means you have to find the dimensions of the muff. So this is your sleeve, or we can say muff. It is a hollow cylinder, and hollow cylinder can be assumed as a hollow shaft. So first of all, find the dimensions of the muff. We know that outer diameter of the muff, capital D, is 2D plus 13. This is the empirical relation to find the outer diameter of the muff. We calculated it as 123 or we can say 125 mm standard value. Length of the muff is 3.5 D, 3.5 into 55, 192.5, or we can standardize it as 195 mm. Let us now check the induced shear stress in the muff. Now we have actually designed the muff, that we have calculated the diameter and length of the muff. But you have to check your design that if this design is safe or not. How will you check it? You will calculate the shear stress based on these two values. And if this shear stress is less than the permissible value, that is 15 megapascal given in the question, then your design is safe. So we will apply the formula for the torque transmitted by hollow shaft. Torque transmitted, that is 1100 into 10 raised to power 3 that we have calculated, is equal to pi by 16 shear stress into d raised to power 4 minus d raised to power 4 upon d, where d is the outer dia and small d is the inner dia. It is the formula for the torque transmitted by hollow shaft. We put the values of these two diameters, that is outer dia as 125 and inside dia as 55, and the crushing shear stress is calculated as 2.97 Newton per mm square. This is for the shear stress for the cast iron, and the shear stress given in the question is 15 Newton per mm square. So our calculated value is less than the given permissible value. Therefore, design of muff is safe. In the last step, we have to design the key. So first of all, based on the diameter of the shaft, which is 55 mm, you have to find the width and thickness of the key. This you can find by two methods. First, you can go for the table in the data book, that according to the table, the diameter of 55 mm shaft, the width of the key is 18 mm. And or otherwise, if you don't have the data book, then you can also find the width of the key based on the diameter, that is width of the key is d by 4. This diameter is divided by 4. So since crushing stress, which is 80 for the key material, is twice the shear stress, which is 40. So if crushing stress is double the shear stress, therefore a scale key may be used. So we will use a scale key, means the width and thickness of the key is same, that is 18 mm. Now we have to find the length of the key. Length of the key we can calculate as L by 2, that is the length of the muff divided by 2. So see in this diagram, the key will have the length which is at least equal to the length of the muff by 2, means half of the key on the right side and half of the key on the left side. So the length of the key will be L by 2. Let us now check induced shear and crushing stresses in the key. First of all, let us consider shearing in the key. So torque is equal to length into width into shear stress into d by 2. This is the formula for the torque transmitted by the key under shear. So in this formula, we will put the value of length and width of the key and find the value of shear stress. The shear stress calculated as 22.8 and it is less than 40, the given value. Now again considering key under crushing. Now apply the formula torque is equal to L into T by 2 crushing stress into D by 2. We put the values of length, thickness and D and just calculated the value of crushing stress. The crushing stress is calculated as 45.6, which is less than the given value, which is given as 80 megapascal. So the calculated values of stress are less than the given values, the allowable values. Therefore, design of key is safe. So in this way, we check the design of key. So this completes our numerical problem, that is based on muff coupling. And in this coupling, we have designed for the shaft, design for sleeve, and design for key. Okay, guys. So after this, in the next video, we will discuss the split muff coupling. Thank you, students.